Hi everyone, welcome back to my channel. I remain your OBGYN Talks with Dr. Ada Zion. Today we'll be talking about hemoglobin genotypes. Thank you for subscribing to my YouTube page. Thank you for following me on Facebook. Please, if you have not done so, I plead with you to do that right now. Click the notification button. We'll be talking about hemoglobin genotype. As a word of introduction, hemoglobin genotype is the genetic constituent of an individual. It resides on the surface of the red blood cell. Red blood cell is one of the components of the blood. We have other components, but the red blood cell is one where the hemoglobin genotype stays. Now, there are four types of hemoglobin genotype. We have the AA, we have the AA, we have the AS, we have the AC, and we have the SS. AA is the normal genotype. AS and AC are the abnormal genotype, while SS is the sickle cell anemia. For people that have hemoglobin genotype AA, they are the ones that have the normal genotype. Those that have AS and AC, they are the ones that have the abnormal genotype. While those that have SS is the sickle cell anemia. AC is rare, but it's also present. It's part of the components of abnormal genotype. Its genotype is one of the premarital screening done for people that want to get married, especially in this part of the world. Now, if there is any mistake in marrying abnormal genotype to an abnormal genotype, a sickle cell anemic child can result. I know the consequences. It is not proper and is not fair bringing out a child just for the sole aim of suffering. That's why the screening before marriage is very important. In this teaching today, I'm going to show you the probability of having a sickle cell anemic child, the probability a child with normal hemoglobin, the probability of having a child with abnormal hemoglobin, which includes AS or AC, and the probability of having a sickle cell anemic child. Using the hemoglobin genotype of the mother and the father, we are going to draw it so that it will be easy for you. Whatever we're going to say here is a probability. Thank you. Now, let's assume that the mother is AA. This is the mother, and the father is AA. Let's do the combination. The combination for them having 4 children and the probability of each of the pregnancy becoming a normal hemoglobin. Now, the first A from the mother combines with the first A from the father, you get an AA. The first A from the mother combines with the second A from the father, you get an AA. The second A from the mother combines with the first A of the father. Remember, this is the father. You get an AA child. The second A from the mother combines with the second A from the father, you get an AA child. This is an excellent combination. So if you see 2 couples and both are the hemoglobin genotype AA, it's an excellent combination. Allow them to get married because the probability of each of their pregnancy becoming a normal hemoglobin genotype child is 100%. It's expected that all their children should be AA hemoglobin genotype. Now let's go. Assuming one of the partners is AA while the other partner is AS. Let's do the combination so that you see. Now, this is the mother still. The mother is AA and the father is AS. This could be vice versa. The mother could be AS and the father is AA. You still get the same result. The first A from the mother combines with the first A from the father, you get an AA. The first A from the mother combines with the second S, the S from the father, you get an AS. Already one abnormal hemoglobin has come in. Now the second A from the mother combines with the first A from the father, you get an AA child. Now, the second A from the mother combines with the S from the father, you get an AS child, abnormal hemoglobin. This is a good combination. What it means is that they have, for each pregnancy, they have 50% chances of giving birth to a normal hemoglobin genotype child and 50% chances of that pregnancy becoming an abnormal hemoglobin child. Why is good here is because none of the children will be a sickle cell anemia. So we have 50% chances for each of the pregnancy becoming either abnormal hemoglobin genotype child or a normal hemoglobin genotype child. Now let's go to the next combination. Let's assume the mother is AC and the father is AS. Or rather, the mother is AC and the father is AA. So this is AC and the mother is AC, the father is AA. We still have this combination. It's a good combination. We still have this outcome. Now, the first A from the mother combines with the first A from the father. You get an AA child. The C from the father combines with the second A from the father. You get an AC child. Abnormal hemoglobin has come in. Now, the first A from the mother combines with the second A from the father. You get an AA child. The C from the mother combines with the A from the father. You get an AC child. The same 50% chances of having an abnormal hemoglobin genotype child, in this case an AC child, and another 50% chances of having a normal hemoglobin genotype child in each pregnancy. In this case 50%, in this case also 50%. Now it is still a good combination. Now what it means is that for each pregnancy, that baby could be AA or AC. For the next pregnancy, it could be AA or AC. The child being AA is not sacrosanct. It could be this or that. However, there is no probability of having a sickle cell anemic child or children, as in this case. Now, so this is a good combination. This is good. Let's go to abnormal hemoglobin couple, both mother and the father are combined together. Let's see the probability of what their pregnancies or children will be. Now, we have an AS mother with an AS father. The first A from the mother combines with the first A from the father. You have an AA child, good hemoglobin. Now, the first A from the mother combines with the S from the father, AS child, abnormal hemoglobin. The first S from the father combines with the first A from the mother, AS child, another abnormal hemoglobin. The S from the mother combines with the S from the father. You have a sickle cell anemic child. Let me explain it, what it means literally. What it means here is that if the woman is pregnant for her first baby, she has 25% chances that pregnancy will be sickle cell anemic child. She has 25% chances that pregnancy will bring forth a normal hemoglobin genotype child. She has 50% chances that pregnancy will bring out an abnormal hemoglobin child, in this case AS. What it means again is that you cannot tell which of the pregnancy will bring out a sickle cell anemic child. This probability is for each pregnancy. It could be that all the pregnancies, let's assume that she has the first pregnancy, it could be SS, the second one, another SS child, the third one, another SS child, the fourth one, another SS child. It means that in her pregnancy, she has the probability of giving birth to a sickle cell anemic child. Is it worth it? It's not. It's not. So abnormal hemoglobin should not combine with abnormal hemoglobin. The same thing with AC should not marry an AS. Let's do so that what we get. This is AC mother married to AS father. The first A from the mother combines with the first A from the father. You have an AA child. The first A from the mother combines with the S from the father. You get an AS child. The C from the mother combines with the A from the father. You have an AC child. Now, the C from the mother combines with the S from the father. This is SS. SC is SS. It's a sickle cell anemic child. So it also means this and this are the same, and this is bad. This is a bad combination. This is a bad combination. So you don't encourage an AC man to marry an AS woman, and we don't encourage an AC woman to marry an AS woman. Two abnormal hemoglobins should not get married. Two abnormal hemoglobin genotype should not get married. Now let's go to SS married to an SS. The combination here is that all the children will be SS. All the pregnancies will produce SS. All of them will produce SS. All of them will produce SS. This is very bad. Very bad. It is not worth it. So you shouldn't risk it at all. Now, I want to explain it literally how you will understand it. A normal hemoglobin man can get married to a normal hemoglobin woman. That means an AA man can marry an AA woman and vice versa. Normal hemoglobin and normal hemoglobin should get married. There's no problem. A normal hemoglobin man can marry an abnormal hemoglobin genotype woman. What I mean here is that if the man is AS and the woman is AA, two of them can get married. See the probability, as I've explained, it's a good combination. The good thing here is that a sickle cell anemic child will not result. An abnormal hemoglobin man should not marry another abnormal hemoglobin woman, or should not impregnate another abnormal hemoglobin woman. Because if an abnormal hemoglobin impregnates another abnormal hemoglobin genotype, the probability that they will have sickle cell anemic child is 25% for each of the pregnancy. And it means that if that pregnancy decides to become a sickle cell anemic child, another pregnancy can as well become a sickle cell anemic child, and all your children could be sickle cell anemic children. So it is not encouraged. It is really, really wrong. It's bad combination. An AC should not marry an AS. Two of them are still abnormal hemoglobin. An SS should not marry an SS. That is very bad. An AC should not marry an SS. And there is 50% chances of giving birth to a sickle cell anemic child for each of the pregnancies. An AS should not marry an SS. So the combination is not advised. Let me go through it again. A normal hemoglobin AA can marry a normal hemoglobin AA, or can get a normal hemoglobin pregnant. A normal hemoglobin genotype is good. A genotype man that has AS can marry or impregnate a genotype woman that has AA. AS and AA can get married. AC and AA can get married. AC and AC should not get married. AS and AS should not get married. Neither are they allowed to impregnate each other because of the probability of having a sickle cell anemic child. AC and AC should not get married. AS and AS are not allowed to get pregnant. There is probability of sickle cell anemic child. AS and SS should not get married. AC and SS should not get married. SS and SS combination is very bad because the probability of having sickle cell anemia in all their pregnancy is 100%. Why AA can get married to SS? You have the probability of having 100% chances of having all your pregnancies to be abnormal hemoglobin, that is AS. AA should get married to SS if they so desire. Hemoglobin genotype is the genetic component of an individual, just like I've said. Bringing out a sickle cell anemic child to suffer is not worth it. The suffering is severe. The crisis can be out of this world, especially in the third world country, where management of these patients poses a terrible outcome. So please, let's help our unborn children. Thank you. If you have not subscribed, please subscribe to my YouTube channel at Dr. Nkiruka Bridget, OBGYN Talks with Dr. Ada Zion. Follow my Facebook page at OBGYN Talks with Dr. Ada Zion. Also, I'm on Instagram with the same name and on TikTok with OBGYN Talks with Dr. Ada Zion. Thank you for watching. See you next time.